37. And Austin, relevance. And Josh, please read the success here.
I will be able to make features and describe the way they are working.
So today we have just one project grade. Next quiz grades Thursday and Friday of this year. Who knows what year the people are watching this video have. But anyway, here's the vocab list. Main ideas. Kylie, number 1. Remember this. Let's hear. Number 2, Wes. Number 3, Michael. Gyres. Number 4, Zach. Yep.
In the middle of each gyre, the water is slightly higher.
Number 5, Andrew.
Number 5, these currents are made by rising warm water and sinking cold salt.
Number 6, Lupe. Number 7, Wes. Kylie, 8. Tyler, 9.
As the water moves north of zero, it gets cold due to the cold and melting into the ice, leaving a cushy hot spell is mixed with icy waters.
Jayla, number 10. Number 11, Lewis.
That's how you say it, right?
Sure. Yep.
There's a change in this pattern that happens about every 7 years.
12, Carly. Number 13, Adrian. Oftentimes when you look at the temperature over the last 30, 40 years, you'll see little spikes coming up, and those are almost always El Nino years. Number 14, Kyle.
El Nino is sometimes followed by La Nina, and that lower temperature.
Okay, next page, part number 1. Next page, please.
Next page, please.
It is next
Stop the talking.
Wait.
Stop talking. Stop talking.
Stop.
Question number 1 on part 1 review. What is the temperature at 60 degrees north? We've looked at this graph before. We haven't answered this exact question before. It's similar to yesterday's. What is the answer, the temperature? Adrian, I'm going to call on you in a moment. Please focus on that. And Lupe, what do you think? Did you say C0?
Yes.
Adrian, do you agree with her answer? Okay, let's look to see how they got this. We look at 60 degrees north right there. We go up to the temperature scale there, and then we have to look at, we have numbers on the right side and on the left side. We got to go to the side that's labeled appropriately, and 0 is going to look out just fantastic. Number 2, a researcher claims that the warmer the water gets, the more salty it gets. Does this graph support that claim? Number 2, does the graph support this claim? Kylie?
Yeah.
The warmer it gets, the saltier it gets. Andrew, do you agree?
Yes.
Okay, let's take a look to see how they got that. Here we have cold temperature 0, and it gets warmer and warmer, and it also gets, let's see here, the saltiness is 32, 33, 34, 35, so the higher the saltiness is as well. However, it stops right about there. Here the temperature goes up, but the saltiness goes down. So no, we can't say that it is a clear relationship. Josh and Kylie, please stop your conversation. Number 3, does the salinity of the ocean at 2 different locations ever get to be the same number? Do you have the same salinity at any 2 places of the ocean? Okay, let's write down your answer right now. Jayla, no. Whatever the commotion is between you two. Answer! What's your answer, Lewis? We're on number 3. Does the salinity of the ocean at any 2 different locations have the same number? I'll come back to you. Kyle.
Yeah.
Okay, Kyle says yes. Lewis, what did you say? Yes. Okay, well, let's take a look. Same salinity. Here, 34 salinity. I go over, and that happens at about 40 degrees to the south of the equator. Is there any other place where it's 34? Well, I can go across, and sure enough, right here, at 40 degrees north, it's also the same salinity. So, yes. Here's 35. Salinity of 35, it happens that place, and that place, and that place, and that place. There's 4 places. About 30 degrees south, about the equator at a couple places, maybe 10 south, 10 north, and then 40 degrees, 30 degrees north as well. Number 4, true or false? Deep currents in the ocean are made partly by icy salt water sinking to the bottom. Michael, I'm going to call on you in a second. Tyler, I'm going to ask you as well. Let's see here. Wes, what do you say, true or false? Yeah. Deep currents are made by icy salt water sinking. No. Michael, do you agree with Wes's no?
Yeah.
Tyler, do you agree with those 2 folks' no's? It's actually true. So as icy salt water sinks, it pushes water around at the bottom and it makes a current. Number 5, surface currents can be caused by winds. The water moves at an angle to the wind. Zach?
Yeah.
Yes. Number 6. Oh, the reason why it moves at an angle is because of the Earth's rotation and what's called the Coriolis effect. Number 6. The Gulf Stream flows southward along the west coast of the United States. So here we have the United States, South America, Canada, and it says here Gulf Stream is moving that way. Is that true or false, Josh?
True.
That is going to be false.
Good.
Number 7, it actually goes the other direction. It goes northwards and it curls around to Europe. Number 7, the El Nino weather pattern happens every year and causes colder temperatures than average. Austin. False, Austin says. Jayla, do you agree with his correct answer?
Yeah.
Yes, false is the correct answer.
Wow.
Number 8, as you go down 100 meters, the currents slow down. Carly. False. Adrian, do you agree with Carly's answer of false?
Yeah.
It is true.
I knew it. Carly, you're wrong.
Number 9, generally the top 100 meters of water move at 90 degrees to the wind.
True.
True, she says. Carly, do you agree with true?
Yeah.
Yeah, it's called that Ekman effect that we looked at video yesterday. El Nino started by winds off of South America getting weaker and not pushing the warm water very far west. That is true. We concluded that the big idea of the hot-cold project is that cold salty water is more dense and does it sink or does it rise? Jayla, the blue water from yesterday's lab.
I wasn't here, Dave.
Oh, I'm sorry.
Really good.
Okay, so Tyler, what did you see yesterday with the hot-cold project? Did the blue water sink to the bottom or rise to the top?
Hey.
Same man, color.
I'm sorry, Tyler, say again?
Same color.
Okay, it should have been sunk to the bottom. At the very first part of your lab yesterday, you should have put in the blue water first. It stayed at the bottom, and the red that you put in second should have stayed at the top. The big idea seen in evidence of the project of the hot-cold project is that the warm, fresh water is less dense, and it's going to do the opposite. It's going to float on the top. So when we look at the ocean in cross-section, we have the land here. There's the big ocean. We basically have cold water that sinks, and then the warmer rises, and it makes a circulation pattern like that, basically. So that's what we call deep currents, and that's what we were hoping to see yesterday in the hot-cold project. Sounding project, task, make a map of a model ocean. Materials, model ocean. If you look in the back right now, you see these long black planks. Those are hiding the topography of the ocean bottom. We're going to pretend that we are doing something called soundings, which is, well, let's read about it here. In the middle of the 1800s, people tried to make maps of the ocean bottom by lowering heavy steel balls with ropes. They would keep lowering it until they hit the bottom. By seeing how much rope was needed to hit the bottom, they could tell how deep the ocean was at that location. This process was called sounding. In this project, you will model the actions of these early map makers. You are given a model of the ocean floor that's hidden between boards. You will lower the measuring stick, much like the sailors lowered their ropes. Your measuring sticks are going to look like this. Very, very skinny to go down these straws. So everybody puts this down a straw, so everybody's putting it down in the right location. Let's see here. You will use the data to draw a map and to answer questions. By reading the questions, you will learn about the features underwater. Your stick will be guided by straws, and each straw is numbered. Do your measurements now. Start with straw number 1 on the left side of the map. Follow the teacher's directions to draw your map. Then read the following passages and answer the questions. So, I don't know if I need to walk you through step by step, but you're going to stick the measuring strip down straws 1, 2, and 3, and then we have these graphs. Here's the data for it. You can draw the depths in centimeters, and then we're going to draw a map. Here, this is going to be for straw number 1. How deep does it go? Does it go 2, 4, or 6? Make a dot. And then straw number 2 goes on the second line. You make a dot there. And then straw number 3, make a dot. And use colored markers to connect your dots so it's easy to see the topography of the ocean bottom here. And then we have more graphs for more of the ocean. After you figure out the shape of that little section of the ocean, you're going to use your context skills to figure out which words go in which blanks, and you'll read this instead of me lecturing on it. All right? This is on Schoology. You have the rest of the period to work on this. We're ready, set, go.